We're now going to look at the factor theorem and algebraic division. So the factor theorem states that a polynomial f of x has a factor x minus a. So in other words, we can factorize it, and one of the brackets will be x minus a if and only if f of a is equal to 0. So that means that a is a numerical value, and if we replace x in our polynomial, then we should get 0 as the answer. So we're going to look at this example here to try and illustrate it. So show that x minus 2 is a factor of this polynomial x cubed minus 7x plus 6. So if we compare it with the actual theorem, we can see our x minus 2 is the bracket, which is x minus a. So we can see that in our case, a is equal to 2. And so what we've got to do is find the value of our function when we make x equal to 2. So if we do that, what we've got to do is we've got to replace x everywhere in this polynomial by 2. So what we're going to do is we're going to say 2 cubed minus 7 times 2 and plus 6. So if we tidy that up, 2 cubed is 8 minus 14 and then plus 6. And if we work that out, that equals 0. So what we've shown then is hence, or therefore, we've shown that x minus 2 is indeed a factor. So the next thing that I'm going to try and do is use long division to factorize f of x into 2 factors. So we do know that from the factor theorem that one of our factors is x minus 2. And what that means is we're going to try and divide this polynomial f of x by the x minus 2. So we're just going to set it up like we would do a standard long division question. So what we're used to when we've done it in numbers. So we're going to set it up like this. And what we're going to do is also replace any of these or any missing letters within here. So i.e. we haven't got an x squared, we're going to replace by a 0x squared. So here we go, we've got 0x squared. And we need that. It's similar to if we had a 0 in the tens column, we'd still put a 0 in as a placeholder. So we do that here. And so we've got then 7x plus 6. And so we then proceed to divide through by this x minus 2. So we're looking at the largest value of x, or the largest power of x that we've got. So we're trying to get the x cubed. So what we'd have to multiply x by to get to x cubed is actually x squared. So then we can write this underneath. So we can say by times x by x squared, we get x cubed. And then we can multiply the minus 2 as well by the x squared. And then we get minus 2x squared. And then we're going to subtract them. And that's why we had the 0x squared there. So we would have something to take away the minus 2x squared from. So if we take away minus 2x squared, then we actually get a positive answer. So we get 2x squared. We take negative 2x squared from 0x squared. And then we just bring down the next number here. So we bring down 7x. And then we're again looking at the largest power of x. And we're trying to see what we'd have to multiply x by to get to 2x squared. So the answer is 2x. So we've got to have a 2x in the answer line up here. And so we will get 2x squared. So then we've also got to multiply the minus 2 by the 2x, and we get minus 4x. So then we subtract that again. So if we've done it correctly, then the 2x squareds both cancel each other out. And so we've got minus 7x, take away negative 4x, So that gives us minus 3x. And we're going to bring down the next number. So that's the plus 6. And we're going to say, what would we have to multiply the x by now to get minus 3x? And the answer is we'd have to multiply it by minus 3. So then we work backwards. We say, well, what's minus 3 times the x? And the answer is minus 3x. And what's minus 3 times minus 2? It's plus 6. So then we can subtract those. And if we've done it correctly, and the x minus 2 was a factor, as we showed with the factor theorem, then we've ended up with 0, which is another confirmation that we've done this correctly, that x minus 2 is a factor of this polynomial. If it hadn't been the case that we'd end up with 0, we've gone wrong somewhere, because if we end up with remainder, that would mean that x minus 2 wasn't a factor of this polynomial f of x. Now that we know that x minus 2 is a factor of f of x, we can actually write f of x as a product of two polynomials. So we can say f of x is equal to x minus 2 times this polynomial here. So the x squared plus 2x minus 3. X squared plus 2x minus 3. And then what we can do, because we have to do this in the question, is factorize f of x completely. So we can take this quadratic here, x squared plus 2x minus 3, and try and factorize that as well. So if we do that, that will actually go into 2 brackets. So we could write x squared plus 2x minus 3 in 2 brackets as x and x, and then we would have a plus 3 and a minus 1. So that means, because we can write this quadratic as 2 brackets multiplied together, we can then replace this in the function as it's written above. So we can say that f of x is equal to x minus 2 x plus 3, and then times x minus 1. And we've done it. So we've factorized f of x completely.